Certain technologies redefine the economic rules of an entire industry overnight. Historically, foundational infrastructure required decades to deploy. Electricity took 46 years to reach 50 million users. The telephone network required 75 years to reach that same milestone, restricted by the physical bottlenecks of manual switchboards. This graph shows those multi-decade adoption curves alongside the rollout of generative AI. ChatGPT reached 100 million users in 2 months. Because this transition is a structural break rather than a routine update, organizations that wait to adapt risk immediate obsolescence. The familiar chat interface encourages users to accept articulated responses without verification. Research indicates that 78% of executives use the first output they receive from an AI directly, without a structured validation process. This creates a significant risk because generative models do not function like search engines. While a search engine retrieves an existing document, a language model uses probability to fabricate an entirely new response from scratch. This distinction separates those who use AI for minor productivity gains from those who re-architect their business processes to take advantage of the model's reasoning capabilities. When a probabilistic hypothesis is mistaken for a finished solution, it bypasses the validation required for enterprise-grade results. This lack of systematic refinement is the primary driver behind the 73% failure rate seen in complex corporate AI initiatives. An artificial intelligence does not read words or possess innate linguistic comprehension in the way a human does. Instead, the system processes information using an atomic unit called a token, which equates to a syllable or a word fragment. Before a model can process text, that information is shattered into tokens and converted into numbers. The model analyzes these numerical strings to calculate the statistical likelihood of which specific token should follow the next in a sequence. Within this framework, intelligence is the result of immense probability calculations, using math to simulate semantic reasoning. Early AI models process data sequentially, meaning they often lost the context of the beginning of a sentence by the time they reached the end. The development of the 2017 transformer architecture solved this by allowing models to process entire sequences of data simultaneously, retaining complete context. The core of this system is the attention mechanism. The attention mechanism maps the relationships between distant words to establish context. It ensures the model understands that bank refers to a financial institution when words like interest or account are present elsewhere in the text. This allows software to evaluate nuance and simulate complex reasoning without the need for rigid manual programming. The model's reasoning is limited by a physical boundary called the context window. This window acts as the active working memory. The system can only reason over the specific information placed inside this boundary during a session. Because of the knowledge cutoff date, the model has no innate knowledge of any world events that occurred after its initial training was finished. When a model is forced to operate outside of its context window or past its training date, it is forced to guess. This mathematical guesswork creates confident but false outputs known as hallucinations. Retrieval-Augmented Generation, or RAG, provides a solution by injecting proprietary corporate documents directly into the context window for the model to use as a source of truth. Managing the context window is the only way to turn a generic model into a precise corporate asset. To govern these systems effectively, leaders must identify where their projects fall on the technical spectrum.
This timeline maps the current taxonomy of AI. On the far left is narrow AI, algorithms designed to execute one specific enclosed task. In the center, we find generative and agentic AI. These systems use reasoning to manage complex, multi-step workflows with minimal supervision. On the far right is the horizon of artificial general intelligence, systems that match human cognitive adaptability across all economic domains. Organizations are currently shifting from managing static code to orchestrating autonomous agents that can act independently. Standard prompt engineering often forces users to start from zero in every session, losing the organizational context required for high-stakes work. Context engineering applies mathematical constraints to the information architecture, reducing the potential for error and hallucinations. This allows for the construction of an institutional brain, a persistent layer of proprietary knowledge and rules that sits permanently beneath the AI model. This architecture ensures that every interaction is grounded in an organization's specific data, rather than the model's generic training information. A proprietary architecture of context creates a defensible strategic barrier that a language model cannot provide on its own.